I'm a principal software engineer at Xeros. So Xeros, I don't want to lose too many words about that because, yeah, I'm not a salesperson and I don't want this to be a sales pitch. We actually do have our global head of sales in here, so Christian. So if you have any questions about, Xeros, what products we offer, he's able to help you. And as Jason mentioned in the beginning, I can show you something with our products and how this actually works in reality. Later. I happen to be one of the program stream leads in data modeling. So together with Mathieu over here, and you can also find my name on many of those standards that we develop here in broadband forum. So I'm also one of the co-authors of the USP standard. So if you have any questions about that, you can always come and talk to me. And for Xeros, I'm also the head evangelist for USP. So I'm actually doing this all the time, like introducing USP to people and explaining what you can do with that. So if you have any questions about how you could potentially use USP, I'm also happy to help you with that. So this is about TR-069 and USP coexistence, and I apologize in advance for repeating some of the points that Zvi has already made, but I'm trying to stay more on the technical level and things that we have figured out in the field without actually, going too much into detail about that. So what are we going to talk about today, or I'm talking about today? So first off, I want to start with a little bit of background information. So again, this is repeating some of the points that have been made already, but maybe I'm able to, reinforce the points and drive them home as well. Then we're going to talk a little bit about the status quo. So what do we see in the fields today, and where do we go from there? So then we have the why and the how. So why would you want to use TR-069 and USP and have them coexist? Then I'm going to talk a little bit about the scenarios that we see. So there are different ways of how you can actually achieve this coexistence. And then, of course, I will be giving a short summary, and then we can have some questions and answers. So the background, TR-069 was first standardized in 2004, but we really see it pick up some pace with the with the publishment of Amendment 4 in 2011. So that's basically when it really took off the charts, and we had a huge spike in actual users. So there are dozens of contributors, which means that it is the de facto standard for device management all around the globe. And basically all of that knowledge that we had from using it as the de facto device standard, device management standard around the world, brought us to developing a successor that addresses some of the key problems of TR-069 that we had, and that were only visible when we actually used the standard in the field. So TR-369, or USP, as you might know it, was actually designed to replace TR-069 eventually, and we tried to stay at as much compatible, let's say also mentally compatible. So we didn't want like a complete change of mind here, but we tried to stay as compatible as possible, so people that are familiar with TR-069 would easily have the ability to transition to 369 without having to relearn everything they know about device management. And of course, there are many, as I mentioned, there are many things that were discovered as not being as great in TR-069. And we are working into addressing those shortcomings and making it an all-around better device management protocol. So the status quo, as we already mentioned, is there are many hundreds of millions of devices which are actively managed using TR-069 in the field. So we do see devices coming in, coming out. Of course, there are other protocols as well, but it's still the de facto standard. nowadays. Some of the problems that we see in the field is that a majority of them are actually legacy devices that are not going to receive any software updates anymore. So the possibility of basically going USP on those devices are rather limited. There are also some other older devices that might not have enough resources to actually implement USP because they're running out of flash or don't have enough memory for that to run both protocols in parallel. Of course, there's always the possibility to basically throw out TR-069 and just go USP. But yeah, some of the older legacy devices, they also don't implement something like TLS. That will, of course, increase the resource usage quite a bit. So that means that we are still stuck with a lot of devices that will not be able to use USP. Also, what we do see, unfortunately, is that the adoption of USP from the manufacturer side is rather slow. So there are a number of devices announced to have USP support, but yeah, a lot of them are not that great as we would have hoped by now. But of course, it's going to change over time. But it's definitely one stumble block when it comes to the adoption of USP. There's also a lot of investments in processes and deployments for TR-069. So yeah, companies, especially operators, have invested billions in their systems to keep it up and running. And of course, no one wants to say, okay, let's start over and do another few billion of investments just to replace something that's basically working. Which is the next point. So TR-069 is often deemed good enough for basic uses. So if your use cases, for instance, are mainly in initial provisioning, so you just want to get the device set up, you want to do some, customer support, etc. TR-069 might actually be fine for you. So what exactly would be the point in changing the protocol just for fun? But of course, as we have already heard before, there are a number of benefits that you can get from USP. And so that's why it is actually quite interesting to deploy for some use cases. So for instance, you have the ability to run multiple controllers. So one device can connect to multiple controllers. So that gives you kind of a separation of concerns, right? So you don't need to actually change your running system to implement new use cases, which means that you're reducing the risk of actually breaking something that already works. So that's kind of nice. If you have a new use case with USP, you can actually say, okay, I'm going to deploy a new system. The new system is just taking care of this one use case. And that means that you avoided the risk of actually breaking something that works and maybe is even very important to your operation. We also have the ability to do efficient in-band data collection. So that's one of the main problems that people that are gathering a lot of data using TR-069 have, that they're basically restricted to using out-of-band communication, which means they have to run multiple systems which somehow need to talk together or exchange information. That makes it rather tricky to do. And with USP, we actually address that. So you can all do it using one protocol, so that removes a couple of stumble blocks as well. Then we do have the ability to do real-time notifications, which means that you can actually react to things happening in the field in real time without having a huge delay. So that enables completely new use cases, especially when it comes to smart home, for instance, but also to customer support, etc., because you can directly react on things happening in real time rather than getting them with a huge delay and then looking at things at a later point in time. One of the things that was also addressed is the way that you can work with the device. So we have actually improved the let's say the command set that you can use in order to do something with the device. And that actually allows a lot simplified workflows. So things that in TR-069 would require multiple commands, and then you need to check the result. And if something goes wrong, you might have to do a complicated rollback or something like that. was also eliminated with USP because the protocol is much more powerful. There's something that I put in air quotes here, which is edge computing. So it used to be like a big term. I haven't heard it for quite a while, but one interesting scenario here is also that you can basically instruct the device to do some of the heavy lifting for you. So rather than gathering data and then processing it on the server side, you can basically tell the device, give me some information if something happens. So you can collect information conditionally, for instance, and that's kind of important if you're supporting millions of devices. So rather than processing huge amounts of data on the server, you can simply say, you know, device, give me the information if something happens. So that, of course, reduces the amount of device that you have to, the amount of data that you have to collect in the first place, but it also simplifies the processing on the server side quite a bit. And of course, you have those always on connections, so that reduces a lot of problems that you have in TR-069 with network address translation. So especially in mobile networks, for instance, that's a huge topic that makes TR-069 almost impossible to use, really. And with USP, you don't have this issue. So what's similar, or how do we get there, right? So as I mentioned, TR-069 and USP actually share a number of very important aspects. So we took great care of making it as compatible as possible, also, you know, from the mindset. So we have operations which are actually very similar. You have something like set parameter values in TR-069 to actually change some data on the device. In USP, you have a set. There are things that you can add on a device. So you can add objects that, for instance, provide configuration. And those would be add object in TR-069 and add in USP. So the basic principles are the same. They're just much more powerful in USP. Also, the data models, as we have already talked about, they're exactly the same, or not exactly the same, but pretty much the same. So we have for all of our data models 2 different flavors. One is for USP, one is for CWMP, taking into account the special needs of the particular protocol. So that also means that if you're collecting data from TR-069 or USP controller, the data structure is the same, the data types are the same. So you can easily transition your use cases from TR-069 to USP without reinventing the wheel. Also, the identification properties or attributes are very similar. So you can still use the same identification mechanisms. You have your OUIs, although there's a slight problem to that, but that's unrelated to the protocol. That's more related to what IEEE and IETF do, but well. You have your serial numbers, you have your FQDN, so fully qualified domain names. That's pretty much identical between TR-069 and USP, which means that you can actually do things like Zvi has shown, that you can have a device that has a serial number and you can see it in your database as one device because you can identify it by the same serial number. Also, the operation modes are almost the same. So basically you have usually, I mean, in USP, you have a few more possibilities here, but you basically have the device that contacts the server. Once it gets to know where to connect the server, you have your notifications. So you can basically say, give me some information when something happens on the device. And of course, if the server wants to do something in the data model, you have your defined primitives that you can use in order to actually execute your operations on the device. Oops. Okay. So with that, we go into the different use cases. So sorry about that again. It seems that some slides were removed. So the first approach that you, of course, can take is basically you have separate systems per protocol, right? So on top, the one with the stick antenna that symbolizes basically an old device, and on the bottom we have the modern devices that actually support the USP protocol as well, right? So that's the most simple approach. You basically have your fleet of already existing TR-069 devices. They connect to your TR-069 ACS. You can do device management and monitoring as you're used to know or used to do. And then you have your separate fleet of USP-capable devices, and they connect to a USP controller. And then you have device management and monitoring. So that's obviously the most simple thing that you can do from an architecture point. So you're basically dividing your installed base into two different groups. You have your TR-069 devices, you have your USP devices. The TR-069 operates on the TR-069 ACS. The USP devices operate on the USP controller. And of course, this is guaranteed to have no operational interference whatsoever, right? You have two completely separate setups, and you can do whatever you want on each of those groups. There's no crosstalk or whatever. Of course, that also means that there are some downsides to that. So you, of course, have a huge resource and maintenance overhead because you essentially have to operate two separate systems. You have, no shared information between them, so you have no coherence. That might provide a slight, challenge in how are you actually going to talk to the devices? How are you working with those devices? And of course, you always need to know, which device to, which server to talk to if you want to operate with a certain or on a certain device. So with that, we come to the next use case. So basically, same as before, you have your old installed device base, and they are connecting to your TR-069 ACS. You can still do your basic device management. So as I said in the beginning, you have the ability, for instance, to run your simple provisioning use cases, initial setup of the device, etc. And then you have your modern devices that still connect via TR-069 to your ACS. So you can still do the same provisioning use cases, etc. But in addition, you have your special use cases. For instance, you want to do some data monitoring, to do some Wi-Fi analytics. And for that, the device could actually connect to the USP controller as well. And there you can run your monitoring. As we've seen before, it's also possible to configure the USP controller via TR-069. So that could be part of your initial provisioning use case that you are implementing using TR-069. So that's a rather simple approach. You already have your existing devices. They are all TR-069 capable as a standard nowadays. You still have your TR-069 devices that are managed via the TR-069 ACS. And you have the ability to configure the initial provisioning via the ACS to actually set up the USP connection on those newer devices that support USP. And then you can have your special use cases implemented on the USP controller. Of course, that's rather easy to set up, and you have very little interference. You can also mix and match controller vendors. So you can still continue to use your existing TR-069 ACS that might be from vendor A, and you can have a USP control layer or controllers. So you can also have multiple, as I mentioned in the beginning, and those could be from a different party or multiple different parties. The nice thing about this is that you have very little resource overhead and excellent usage. So also you get all of the benefits that you want to get from the USP protocol, but you're not implementing something that changes everything how you operate with those devices, because you're really only doing the things that USP is great at on the USP controller, and everything else stays on the TR-069 ACS. Of course, if you do it that way, it still means that you don't have any coherence between the data on the devices, because you have multiple systems that basically don't talk to one another. So you still need to know where to look for the information, and yeah, it's still separate systems because yeah, you don't know exactly what the USP system is, or the system is doing, basically, because yeah, you have those two different protocols, you have those different systems, and they have no connection to one another. So with that, we basically go to the next scenario. So this is pretty much the same as before, but you can see that this basically changed from a line to a plus. So now actually the systems know about one another and have a connection between them. So this could be either API or this could be database. But that basically means that the system know that the other systems exist and they can actually share information about that. So this is not quite as simple to implement. But as I mentioned, this is quite similar to what we just saw before. So you have your TR-069 set up for your basic provisioning needs. You have your USP set up for your special needs and efficiency. But actually in the back end, you are sharing the data. So either you have your APIs or you have your database, and that will solve the problem that you have this complete disconnect between the devices, and you always need to check where to look because you know what is what and what is there and how to access it. So basically that means that you have rather little resource overhead and still excellent usage, but now you actually get the coherence that you want between the different protocols that you have. Of course, there's also some downsides to that. So, creating this particular interface, especially if those are systems from different vendors, for instance, that of course creates a little bit of a challenge to implement that and get to that. And of course, there is some cognitive and maintenance overhead because you now have this additional connection that you need to worry about. And yeah, people need to be trained to know, what kind of data is shared, what kind of data is only available on separate systems. So you have this additional linking of the data, and that can also create some challenges. And then, of course, this is the solution that we all want to get to. You have your native multi-protocol implementation. So you basically have your TR-069 devices, you have your USP devices, you have your TR-069 ACS and USP controller functionality, so they're all deployed in the same network. They're all based on the same system, and then you can have all of your use cases implemented on the system, and it really doesn't care whether you're using TR-069 or you're using USP. So this gives you the ability to basically say, okay, whatever the device supports, we can directly support in our system. It's one system, it's most efficient, and we can have the most benefit of both protocols. So the interesting part here is it's actually rather easy to achieve. So if you have a capable multi-protocol device management system, it's not a problem to set up. So basically, usually it only involves a upgrade of the systems, and of course you need to work out how much more resources you need to actually support, a lot more devices and those persistent connections. But yeah, it's rather easy to implement because you just need to upgrade your software, basically. That also gives you the most efficient operation. So you, of course, have the least overhead that you can possibly achieve. And you have full device visibility because it is a single system that has the data shared regardless of the protocol that's actually used to access the data on the devices. You can use TR-069 and USP concurrently for most benefits, so you don't need to differentiate between use cases, what you want to do. You can simply use whatever the device supports. So for instance, it's also possible to say, okay, we have a USP capable device that has all of the abilities that TR-069 provides, also on the USP side. And then you can basically just say, okay, I'm basically turning off TR-069. I'm only using USP for this device. So this gives you, of course, the most benefit of the new protocol. And yeah, you can use all abilities of the device regardless of the protocol. Yeah, so the downsides, of course, are you need to worry about upgrading your whole infrastructure, right? Because when you have more devices, more persistent connections, more everything, that means that you need to have new servers in place. You might need to upgrade your RAM. You might need to buy more resources on your cloud provider, whatever it is that you do. But this is basically upgrading an existing system, so that's typically more involved than just, you know, providing a separate system in parallel. And of course, if you're stuck with an rather old system, or from some vendors that don't offer multi-protocol capabilities, then this might be actually rather tricky to do or even impossible. So depending on what you have. So the key takeaways for me here are the Broadband Forum has actually put a lot of effort into making sure that we have this ability to evolve on the TR-069 usage that is, as we said, out on a lot of devices in the field. And it's a key driver of you know, broadband use in the field. And of course, we have taken that into account, and we try to make sure that we have the best possible path forwards, and yeah, the least kind of mental troubles to actually adjusting to a new protocol. One interesting aspect here is that we can actually leverage TR-069 to use it as a launch pad for USP use. So we have the ability to configure the devices using the TR-069 protocol for USP. We have the ability to have those combined hybrid approaches that I mentioned before, where you basically use TR-069 for some use cases and USP for other use cases. So the interoperability is really great. We also have this compatibility of the operations. So TR-069 workflows actually can be rather easily migrated to USP with little or almost no changes. Basically, it's just the names of the workflows that, the names of the messages that you're using is changing, like from set parameter values to set. But apart from that, everything is the same because you have the same data models, you have the same mindset, and you don't need to use those additional capabilities that USP gives you, or those, you know, enhanced capabilities. So you can actually just take your workflows, translate them, and that will work fine. Of course, it doesn't give you the most benefit, but from an implementation standpoint, that makes it rather easy to migrate. We also have those two data model flavors. And they're essentially twins. So most of the data is going to be the same, except for some changes. Of course, if you're still using TR-98, which is the long obsoleted data model, but unfortunately it's still widely in use, then this doesn't apply to you. So that makes things a little bit more tricky, but well, some people choose to do that. And also we have, you know, those different paths that we can take for the parallel use of the both protocols. So regardless what people think, this is not going to be like a big bang approach where you say, you know, I have to change everything at once and hope that it works. But there are many options that are available. So it's rather convenient to make this migration and take it basically slow. And yeah, all of the mentioned options are actually field proven. This is not meant to be like an, let's say, total or conclusive list of options. So there might be others, but those are the ones that we are definitely supporting in the field and have customers for. And yeah, that's the key point here. Right. And with that, I would like to thank you for your attention. And if you have any questions, go for it.
Thank you, Dana.
Yes, hello, Peter from Icotera. You mentioned that many options for simultaneous TR-069 and 369, but does TR-069 complement the new USP in any way, or can we just from the beginning as a manufacturer completely forget about TR-069 and go fully with USP, or the current version is not supporting everything or something?
No. So if you want, you can absolutely go for just USP support. You might have the problems with the operators that have those, billions of investment in their TR-069 systems, saying, we are still using TR-069. We are in the process of, moving over to USP. So if your devices only support USP, that might be tricky for you. But yes, you can everything you can do with TR-069 you can also use with USP. So in theory, that would be a viable option.
Hi, Daniel. Arne Schulz from Vodafone. You mentioned at the beginning this challenge about device manufacturers not quickly picking up USP, or
Yes.
even devices with low specs not being able to run both in parallel.
Yes.
It's a problem we also see. What is your typical recommendation? Are there any easy answers like ignore devices older than 3 years, or any magical solutions you're proposing?
No, unfortunately, it's not quite as easy as that. So we are working with a lot of manufacturers to actually make sure that, they are not just, let's say, paper launches of the USP capabilities, but that it actually works and is useful. So we see different, let's say, quality levels of the implementations. And yeah, we are trying to enforce that, but there's no real guarantee. And if the device manufacturers say, so usually it's not that hard. So if your device is, let's say, maybe 8 years old or even slightly older, it shouldn't actually be a technical problem to implement USP. But of course, some device manufacturers might not be happy to do an investment on an old device that they don't want to sell to you, but they would like to sell, newer devices, right? So that's more of a, let's say, operational challenge that's coming from the vendor side rather than really a hardware problem or a lack of resources on those devices. So technically, it is possible to implement it on very old devices, and there are some vendors, some are even in the room, that are very good at supporting older devices and upgrading them with the latest capabilities and features. But talk to your vendor and pressure them to actually implement that, and it might be fine.
I saw it. Oh, here you go.
Yeah, definitely. Icotera as a vendor is very good in supporting our customers. So, but regarding the USP, for me, it's a chicken egg problem. I'm the main architect of the Icotera. And I had hard times to persuade my C-level management to put resources and money into the implementing USP as our protocol. Because we don't have, ISPs that really want to use them. And my question for this is, do you have any data, for example, any statistics, how many ISPs are interested in adapting this protocol, or how many did it already?
Yes, I cannot go into too much details, but actually I can tell you that most of our customers are interested in going to USP. Some of them are using USP already. So yeah, you can definitely expect that over the short or middle term, everyone is at least looking into it, and middle to long term actually moving to it. So this is happening. It's not a question of, if, it's more a question of when.
I would also take a look at that Omdia report that the Broadband Forum put out in October, because there's a lot of data in there too. That fundamental slide that I was showing at the beginning is basically that was 111 operators from almost every region. It was very, very diverse in the people who responded to that survey. And that was 86% of them were going to. I think 29 had already done it, and then the rest were in the next 6 to 18 months.
Indeed. So at the moment, it's really the lack of devices that basically are slowing down the implementation. But pretty much everyone is looking into that, and a lot of them are actually using it already.
Daniel, can you a little bit elaborate? Are there additional performance requirements for a gateway if you move from TR-069 to USP? And in the USP implementation, in the beginning, you just do the same what you did before, you know? Maybe it's even less or the same or more. That's my first question.
Additional resources, not technically, because one of the most intensive or most resource expensive use of TR-069 is actually the communication itself, because you have those handshakes going on. So if you're using TR-069 extensively, like connecting to your ACS every 5 minutes, so you can collect some data, that's actually very expensive in terms of TLS handshake, for instance. So in that case, USP requirements are even lower, because you basically establish the connection once, you have your TLS handshake once, and then the connection continues on. So that is even more efficient than using TR-069. So it always depends a little bit on the use case, but it's not necessarily that USP is more expensive in resources than TR-069. It really depends on the use case. Of course, if you're talking about a 10-year-old device that doesn't even implement TLS for TR-069, and unfortunately those devices still exist and are used in the field, despite being illegal, at least in Europe. But yeah, then the situation is a little bit different. But any proper implementation of TR-069, depending on the use, USP might actually be more efficient.
So the USP is more efficient than the previous one.
Yes.
Okay. So you say that, but what you can say, 80% or 60%?
It's hard to tell, because it really depends on the use case. But for instance, as Sui has shown, it's also more resource efficient on the network side. So it might actually save you also some other costs there. And yeah.
Oh, interesting. And second question, maybe you can say something officially about USP and RDK.
Officially?
Yes. because you are, or what you can say here on that round, in the competitions with WebPA and things like that.
John wants to say something.
John Blackford, Vantiva. Actually, we did an integration of the OBUSP project into RDKB, so it is there, but I believe it is disabled by default. So it's kind of like a compile time update that you have to make to get it up and running.
And that's as official as it will get.
I do want to bring that up, though, about OBUSP agent. Not just OBUSP agent, but one of the things that it's interesting to me, because I hadn't thought about much about the uptake on the device side until people were bringing it up just now. And the Broadband Forum has put mechanisms in place to make that easier by having open source reference implementation that John was just mentioning, right? That is being incorporated into the open source platforms. But again, that's a reference implementation. I know that other companies are actually working on building implementations to help people make this transition.
Some are even dual stack, like you get 2 protocols for the price of 1.
And so it's cool that the the device management vendors that are out there are all working to help make this transition easier. And interestingly enough, the majority of the participation in us building the protocol are our device management vendors and operators. And so it's a nice little pairing that I think is going to help make everybody make the transition a little bit easier.
Right.
And do you know maybe some open source controller implementation? But we have many agents, but most of the controllers are behind paywall. So it's hard to test these agents.
Yes. Sorry about that.
So if we're talking about testing the agent, I mean, that's basically where we come in at QA Cafe. If you're doing it, if you're not doing it in a live environment, the test harness exists to run through the entire certification program and to do all of your data model validation and all of those things. But that's in a test environment perspective. There isn't a open source controller to sort of just bang against,
But as our customer, you might want to talk to our people, and we will help you with that.
So, Daniel, one of the things that I'm noticing when I'm talking to people about the difference between USP and TR-069 and the transition over, that they have a little bit of a difficulty in wrapping their minds around some of the new concepts like the commands and events that we put in there. Is that something you're also seeing? And if so, how are you kind of helping to bridge that gap and get them to think differently?
Yes, so that's actually one of the challenges, but funny enough, a lot of people don't realize that in TR-069 the ways how you do things is much more diverse than in USP. So in TR-069, some operations like a firmware update are done using special RPCs. So that's like a completely kind of interface and protocol that you're doing. Other things like diagnostic tests are run using the data model. So you're basically doing set parameter values on the data model, and then you get a notification, and then you fetch the data from the same data model again. So that is indeed a little bit of, let's say, a challenge to adapt to the ways the same works in USP. But it's actually much more unified. So once you grapple with how that actually works, so basically you're setting up for asynchronous commands, for instance, you're setting up a notification so you can actually receive the results, and then they will be delivered to you right with the notification. And then you execute your command, like you do your firmware update, or you do your diagnostics test. Once you understand these concepts, it's actually easier than in TR-069. But yes, that's indeed the most challenge that you have. That those special operations like firmware upgrade, reboot, and the whole notification system works a little bit differently than in TR-069. Yes.
Somebody had asked about the overall efficiency. I wouldn't say that there is anything that TR-069 does better at this point. No, not really. Right. And one of my favorite graphics that Tucker at QA Cafe came up with, which I love so much, is this diagram. Okay, it's too small. Right. And the difference, and this is just the amount of communication, let alone the footprint of the code itself, right? And the differences between how many steps are required to get information in TR-069 versus but along the lines of footprint, outside the bounds of whoever is writing the agent, and the open source agent itself, USP is designed to have much smaller footprint on purpose. And there's always Tim Spetz in the room at all times being like, hey, what about those really, really dumb small devices? We have to think about them too. So we listened to him. Usually we don't at first, and then we eventually did. So everything about USP is designed to be more efficient, at least one way or another.
Yes, of course. The problem is, with the ability also comes the desire to actually use it more. So what we are seeing in the field is that since you now have so many more capabilities and possibilities, and you can, get your data faster and more efficient and everything, that people just say, okay, I want a lot more data. It's like, oh yeah, the protocol is more efficient, but then if you fetch 10 times the data, it's still going to be a challenge for you to process that all. Yeah.
It's a victim of its own success. We do. Oh yeah. This is one of the best things he ever made. We have it on our main USP training page, and it's the best one.
So yeah, Matran from Orange. So yeah, I often ask this question because we were mentioning all the benefits of the always-on connections and maintaining this for reachability, to be able not to go through the NAT and so on. Right. But what the question, I think you know where I'm going.
No. Don't throw me under the bus.
Is okay. So it's much more efficient, but it's also requires much more resources to maintain those persistence connections. And how do you deal with this? I mean, we are talking about millions.
Yeah. So it's actually a solved problem, right? So if you look at the let's say the industry and where other industries are going, it's basically you have those always on connections, right? You have your smartphone connected to your messaging server all the time, so you can receive push notifications and things like that. So the persistent connections are actually a solved problem. It's just that the mindset needs to change when you want to deploy such an architecture. People are still thinking in terms of how many connections do we need to establish? So that's also something that we see, for instance, from cloud providers. They only dimension the systems according to, how many connections do you establish per second, right? How many parallel connections at the same time? Yeah, with USP, it's completely different because all connections are on at the same time. You pretty much have no, connection establishments going on most of the time, unless the device goes down, network goes down, something like that, they will be always there. So it's a different mindset to actually architect the overall deployment and design it. But other than that, in real life and operations, it actually feels quite comfortable because you have like the static load. You always know what's going on. You always know what to expect. So it's not that you, for instance, have a sudden spike in a number of connections that will throttle your server infrastructure because you didn't account for 1 million devices coming up at the same time due to some weird event that's happening somewhere in the world. So that's actually quite comforting, and it's really only a change in mindset, but not really a difficulty of actually getting there.